Good morning, everyone. Welcome. I'm Ian, and you're tuning into our weekly Coastal Drone live stream, where we're going to deep dive into all things drone related, bringing you the tips, tricks, and insights you need to elevate your drone piloting skills. This week, we're tackling a crucial topic: data management. I'm going to walk you through different storage solutions from external hard drives to cloud storage and share some backup strategies to ensure you never lose a precious shot. Joining me today are my co-hosts, Jen and Finn, fellow drone enthusiasts and pilots who bring with us a wealth of knowledge and experience to the table. Remember to hit that subscribe button and join our community of drone enthusiasts for weekly updates. You'll not want to miss out on all the tips, insights, and community support that we offer. So first off, why does this all matter? Well, drones are aerial data capture tools, right? They take data and they store it, right? They're flying cameras, they're flying sensors. They are tools that are used to convert all that information into store and actionable and usable data. Whatever you're doing, you're going to produce gigabytes upon gigabytes of data. Right? We usually don't recommend you buy small cards anymore because an hour of filming can fill a card pretty fast. The reality of what we're doing, though, is this data has immense value because it takes time, money, and effort to create. This stuff is not free. You lose your data, you lose your work product, you lose the value that you've built into that effort. 4K video bit rates. So your average camera these days is 200 megabits per second, which equals 25 megabytes per second, getting it back into like what hard drives are, or 1.5 gigabytes per minute, or roughly 90 gigabytes per hour, right? So if you have a memory card that's 64 gigabytes, you'll fill it in roughly 45 minutes, and that's one card. And now you got to store that data because it has value, because you may not ever be able to get that same shot or that same sensor value or something else. That circumstance may never happen again. Just for an example, the podcast we're doing right now, the raw footage from this, we have 3 cameras rolling. It's usually about 240 gigabytes per hour to run this footage. And this is only being captured in 1080. So think about how much data we're generating from this. It's really important to have a plan and stick to it. Real quick about my experience. So long before I was a drone pilot, long before I was a helicopter pilot, I managed data networks and servers and storage systems. So I was responsible for a network that had thousands of people that accessed it. And we had, this is 20, 30 years ago, like tens, if not hundreds of terabytes of data. If we didn't have a management system or a way to organize that storage, it would have been a complete nightmare. So you want to have a plan where how your files are going to be sorted, where they're going to be saved, how you're going to access them, and then stick to that plan. And stick to that plan for as long a term as possible until it no longer works. And then go back and review it and maybe start migrating that plan. You can create yourself a wiki or a Google Doc or a note or something. Just don't do something that you don't understand, and don't do something that doesn't make sense to you. Because at the end of the day, 5 years from now, when you need to find a file, if you can't find it, if you can't understand where it is, then what value is it to you? This is one example on the screen here. So we organize our jobs or our shoots by year, month, day, client name, job. So right away, we're starting to build out some rough metadata or some information about that job at the file structure. So then when I look at a file and I reference where it is, I know where I can find it and where to go from there. I really want you to think about things in a process. So we talk about drone piloting and our SOPs and our checklists and procedures. This is all an evolution of that. Whether you're doing this for fun or you're doing this for business, this is the same. You need to dump your memory cards daily. Do not go multiple days with your SD card from your drone sitting in your drone or sitting in your bag, not copied somewhere else, because circumstances will happen where you'll charge all your batteries up and you'll be ready to fly again. And then you get out there and you realize, oh, this card's full. Is this important? I don't know, probably not. And then delete it or format the card or not realize that data isn't backed up somewhere else. So if you say every day at the end of the day, the last thing I'm going to do for my business day is dump my cards to storage, to something, not my memory cards, then every day is a new day, and I know I can start off fresh with the cards. And to go hand in hand with that, you need to carry some sort of solid state storage that is more than just your memory cards. So, for example, we looked at our essential gear last week. This is a SSD that has been put into a USB enclosure that I can plug in. This thing's, I don't know, 500 gigs, maybe a terabyte. and it's fast. It's important that it's fast because I need to be able to dump all my cards to this, and then I can dump this to my next system very quickly instead of spending the same amount of time copying off my memory cards because memory cards are slow.
So you're putting your SD onto this.
Yes.
And then you're plugging that into your computer.
Exactly.
So now the SD is good to go, and then that's doing the work.
Yeah. Take your memory cards, dump them to this so that you've got something portable and with you that is, because like laptop storage is really expensive, especially on a Mac. This is, let's say, $150. What I want to do is take my memory cards, dump them to the bigger storage. Now my memory cards can go back in the air. And if I lose my drone, I don't lose my entire day worth of shooting, first off. So there's my first backup. The data can stay on the card until I need to format them. The other option is to have multiple cards, and then you just keep changing cards as you change batteries to reduce your risk. This SSD, so this solid state hard drive, needs to be moved off to something else, right? So you cannot keep all your data on just this one. If this is in your car and your car gets broken into, gone. So then the next step is that has to go on to some sort of additional storage. And we recommend RAID is what you'll see on the screen here. And RAID stands for Redundant Array of Independent Disks, right? So this is one disk. A RAID would be 3 or 4 or 5 of these, right? More than 2, ideally. And the idea is it's something called N-1 redundancy. So if you have 10, you take one of these away, you still have 9 disks that work, and the data is shared across all 9 of those disks. So you can then replace that dead disks with another one, and it rebuilds across all 10, and then you're back up and running. And as far as people wouldn't have any idea that you've lost one of your hard drives. If you have a stack of USB hard drives, if you drop one of those, especially a mechanical hard drive, dead instantly. You cannot risk dropping a hard drive because it's a mechanical, and the heads or the read-write needles inside of a hard drive, they can bounce and scratch the platter and destroy all the data on the disk instantly. If you've bought a computer in the last 6 years, I think is a safe bet now, that's more than like $500, it's probably a solid state hard drive. It may not, like, speed's going to vary, but at least you're running less risk of physical damage to your data. But solid states are not impervious to surprise data loss because this is an electromagnetic storage device at the end of the day. And electromagnetic storage does degrade, does die eventually.
Mm-hmm. I think the average fail time for a solid state drive is between 5 and 10 years.
Yeah.
They're more reliable in those terms, but they won't necessarily last longer. Like they won't last forever.
There's a video out there of a guy in a data center, and he was showing all the servers. Like, you can see all the lights, the activity lights of the hard drives. And then you can see like a graph showing the throughput of the servers as they're moving data. And he's like, check this out. And he screams at the server. He stands there and just screams right at the server. And you see the throughput of the server and all its operations drop like this because the vibration of his voice in a noisy data center is enough for all the hard drives to panic crash and stop. And it goes into protection because of that vibration, because it is so important that hard drives don't shake. Get that data onto a RAID. We're going to talk a little bit more about RAID. Get that RAID backed up off site, right? So if all your data backups in the world are no good if your building burns down, right? If your server gets stolen, again, everything's physically gone, you're done. The core idea of all this is the 3-2-1 backup strategy.
So the 3-2-1 is kind of the mnemonic for the industry standard on how to organize your data. And it goes like this: 3 copies of your data on 2 different types of hardware with at least 1 stored off-site. 3 copies of your data that could be on your laptop, on your server, on Google Drive. If you've put it on Google Drive, it's now in 2 different formats. And if you've put it on Google Drive, one of them is now off-site.
And potentially backed up across multiple different types of servers and different data center locations, right? Mm-hmm. You're putting a lot of faith in that system, but if that's your 3rd tier and you're putting faith in someone else for your 3rd tier of data storage, you're still light years ahead of your average person out there that's doing data management. So on the screen here, we've got kind of the workflow. You go from your SD card to your portable SSD to your office NAS to cloud storage. Do not use fake cards. Do not use cheap cards. There is no good that will come from cheap storage. If you don't have redundancy in that storage, it is not worth the risk because this is your livelihood. You're running a business on this data, right? The last thing you want is cards to be lost. For micro SD cards, which is in pretty much most DJI drones and other drones because of the form factor, the weight and everything else, and so all the way up to like the Mavic Pro and everything, you want to look for something that's got that V30 U3A2 rating, right? So that's how fast the card is, how fast it will write. The U3 is the write and read speeds. The V30 means that it's designed to guarantee 30 megabytes per second or better, which is more than 200 megabits per second or better. And the A2 is how quickly the card will randomly access. So if you want to run, it's an application speed rating. So if you put it in your phone and you want to run apps on it, that's where the A2 matters more. It doesn't matter as much on the drone, but again, don't cheap out on cards. Get a good quality brand card. Get the right card. I'm typically using SanDisk or Lexar. Go down the list of DJI recommended cards. They're all good cards. Episode 2 or 3 of this year's series has a deep dive into cards that we recommend. Portable SSDs. You need to carry enough storage for a few days to up to a week worth of work. I don't recommend carrying more than that because you're going to, if you have it, you're going to fill it and then you're not going to back it up. If you're carrying around 10 terabytes of data in your backpack and your backpack gets stolen, well, now you've lost 10 terabytes of data. Now you got to stress about, did I back that up somewhere else? Right. So you want to be as lightweight and as nimble as possible, but not corner yourself into doing a 5-day job and not having enough emergency or your intermediate storage available to you. So I usually recommend 1 to 2 terabytes for what we're doing for video and photo acquisition. If you're doing LiDAR data, that might not be nearly enough. If you're doing 8K video, for example, on an Inspire 3, that definitely won't be enough because 1 terabyte will be destroyed in under an hour. So it's going to scale based on what you're doing. What I do recommend though, and this is one particular thing, again, just like the memory cards have certain specs that you need to watch for, USB is a complete nightmare these days when it comes to speed rating and everything. And we've talked about this before, but to simplify it as much as possible, get a USB-C hard drive that is generation 3.2, Gen 2x1. That means that it's rated for 10 gigabits or better. If you have a Mac and it supports Thunderbolt 3 or better, you're kind of in the same kind of spec. Just make sure that it's a 10 gigabit USB-C connector. You can always connect it back if you don't have a USB-C port to older computers. But if you have a faster computer, you want the best, because otherwise you're going to be spending forever moving data back and forth, especially when it gets big like this.
The ribbon cable you buy at the gas station will not be sufficient for this data transfer.
It will not. It's the girth of the cable is usually a good indicator that it's a high-speed cable. Buy the recommended cables, buy the recommended hard drive enclosures. If it doesn't charge your phone, then it's obviously not going to move data, right? Okay, network attached storage, NAS, not the wrapper, the server. This is at a high level. We're going to get into specifics, but at a high level, it's a storage server that's dedicated to has one job. It's a computer that sits in your house or your office that has one job. It sits on your computer network at home, either wireless or Wi-Fi or wired, and has more than one hard drive bay in it. And it takes those files and copies them at a bit level or at a binary level across multiple disks. So if one of those hard drives, the mechanical hard drives, fails, because we still recommend using mechanical hard drives for big storage because it's cheaper, right? If I want 20 or more terabytes, it's going to be cheaper to buy mechanical hard drives than it is solid state, right? Solid state's really fast, but it's expensive relatively. Big old hard drives are better for storage, but they run the risk of failing when you yell at them, literally. So you need multiples. And in order to do that and safely do it, you need an enclosure that automatically copies them across multiples. One of the things that I recommend, and it kind of goes into our strategy and how we do data, is to ensure that it supports cloud sync at its headless level so that the box itself automatically synchronizes to the cloud and then has, like I said, a redundant array of independent disks. And then the final part of the strategy is the cloud storage. At a high level, it should support offline synchronization. So what that means is not only is it on the cloud, but you can also synchronize it back to your computer so you can work with it without the internet being on. So you can take it on the road, take it on a plane, edit it at a high speed, especially if you're on a slow internet connection. Because if you're out in the bush doing data acquisition in the bush, it's going to be slower internet most likely and not fiber or whatever you have at home. It needs to be cheap. It's usually going to scale on a cost per user or a cost per gigabyte. So the more you put on the cloud, the more expensive. So you're going to have to decide where the trade-off is. And then one of the other things is make it seamless so that you can take that data and deliver it to your client. Because again, if you're delivering raw footage or raw photos or LiDAR, it could be 100 gigs or more. You're not sending them an email, for one thing. And it's not cost effective necessarily to buy a hard drive and deliver it every single time. You want something where you can easily send the customer a link and be like, here's your footage. Have a great day. So let's talk about the hardware. I highly recommend using a Samsung T7. I've been using Samsung SSDs for 20 years almost now, since the first ones came out. And they've been very reliable for me. I've probably personally installed over 100 SSDs in computers, and I've managed computers and seen maybe one of them fail. They're not the cheapest, but they're also not the most expensive either. This one, I think the 1 terabyte is probably 150 to 170 Canadian. The 2 terabytes probably around 200 and something dollars. Either way, the links are going to be in the description and they'll go to the current price. I use Keepa on Amazon to keep an eye on prices, and it'll tell you historically what it was, and then you can go back and see.
If you're in Western Canada, the tech store that often has the best sales on digital storage is London Drugs. A card that would normally be like $150 to $200, you could probably get that for like $120 or $100.
Yeah. We're not going to recommend anything that's third party or no name when it comes to storage, especially if you're running a business.
The Temu 1 terabyte drives, you plug it in, it says 1 terabyte. They don't have 1 terabyte.
That's true. That's actually, there is a lot of fake drives out there that you can make a computer think it has more storage than it has, and then you try and load an 800 gig file in. What'll happen is it'll take that 800 gig file into that 1 terabyte disk, but in reality, it's only a 100 gigabyte disk. And it's just written that 800 gigs over the first 100 gigs 8 times. And now you've lost the first 3. It verifies it's done. And then like 2 weeks later, you go and plug that disk in. And it's like, why does this video start at like the last 1/8 of my video, if it even opens, period?
Yeah. Or why are there only 100 photos instead of 1,000? Basically what we're saying is if it's too good to be true, it probably is.
So the Samsung T7s, one of the key things, the reasons I recommend these, not only are they really good and rugged, they're actually, you can plug them directly into an iPhone or an Android that has a USB-C port, and you can move files to and from that SSD off your mobile phone because they're low power. They don't cause problems trying to run them off your phone. So since Apple went to on the iPhone 15 Pro, it's got a USB-C port. You can record directly to SSD in the camera mode. The T7 will work perfectly for that. We are currently using SanDisk Extreme Pros. There is allegedly a problem with them, and there's been some data loss reports. There's news about this. It's a known thing. There's some lawsuits going on. Again, super risky. So Samsung, reliable, a little more expensive. You're paying for that insurance. Hard drive NAS server. This is the Synology DS1522 Plus that we're on screen here. The Synology is a self-contained server that sits on a shelf in your house or your office. This one has 5 bays. So it has 5 full-size hard drive bays that you can put any size capacity hard drive into it, but you want to put 5 of the same size when you start. It also has 2 slots for SSDs like this. So the ones that are inside this container. It's called an M.2 SSD, right? It's just a PCI card. You would have 2 of these that you could plug into the NAS. They don't add any more capacity, but what they do is they add speed. So if you're working with a huge data set and it's got tons of random files that you need to search and move like a database or something, you can add these into that NAS, into the server, and it'll improve your performance. So if you want to scale up from 1 or 2 people to 10 or 20, that's where you start seeing performance problems. This is scalable. This one's about $1,000 Canadian for the enclosure, for the server, right? And then you would pay for the hard drives on top of that.
Oh, that doesn't come with them?
No. So it's just a box that you put hard drives into. The reason I recommend this one is it's got 4 network jacks built into it that are gigabit. So you can actually have multiple people hooked up directly to it and it won't saturate the network. And you can upgrade it to have 10 gigabit as well for a couple $100. So again, you can scale from small, medium business all the way up to a medium-sized business of like 100 people could probably work with it depending on the workload. The other thing that's really important, and like we talked about, it supports both snapshots, which are essentially in-server backups. And a snapshot is you take a point in time and then you measure all the changes to files that have happened from that point in time to the next point in time, and it only saves the differences. So if you've got 100 gigs of initial data and then you add 10 gigs to the server, it's not backing up 110 gigs on the next save and then 120 gigs on the next save. It's only backing up either the 10 gigs you added or however many files you deleted in between those 2 points. Like if you've used a Mac for the last, 20 years, Time Machine is exactly what this is. Time Machine lets you go back in time to a date in the past and it will pull those files forward. A snapshot lets you roll backwards, and snapshots are more efficient. Where is the March 22nd version of this JPEG? Searching, found, restored. Okay, we're back in business. You need to fill that server with hard drives. So that one has 5 slots. And if you fill all 5 with 8 terabyte disks, you wouldn't have 40 terabytes. You'd have 40 terabytes of raw storage, but you need to reserve some of that storage for failure. In this scenario, you've got 3 of those disks are visible and the other 2 are kind of semi-transparent. That's called Synology Hybrid RAID 2. And what that does is it has 2 spare disks that if any one of those 5s were to get yanked out while the thing were running, it would still chug along, no problem. It would start beeping and get mad at you, but it's saying, hey, I need a new disk, or else if one more disk fails, you're going to lose everything. Not just a little bit, you're going to lose everything. So you get 24 terabytes of working space, and you have 2 disks that are your insurance policy. You can go down to single disk or SHR1, single disk redundancy, which means you have more space, and you can always migrate from 2 to 1. If you feel like running the risk and you don't want to run more disks, you can do that, but you always want to start at the highest level redundancy and work backwards.
And do you set this up in software, or is,
yes?
So when you plug this into your computer, and then you have like a menu to set this up?
For Synology, it's totally self-contained. So you take it out of the box, you put it on your desk, you load the 5 hard drives into it, and it asks you right out of the box, what level of redundancy do you want? 1 or 2 disk failure? You say 2 disks, yes, please. And it says configuring array, and it'll build everything, and it'll present you with a folder and say, here's your folder. You then connect that folder to your Mac, to your PC, to your phones. There's apps for it as well. It'll work over the internet, just like cloud. When you upload photo.jpg to it, it then splits that JPEG file into multiple bits and stripes them across all those hard drives, all 5 of those hard drives.
So it's one picture across all of the...
There's 5, you can say there's 5 copies of it across all hard, but they're not necessarily copies. It'll take that file, split it into 3 or 4 or 5, and then start divvying it out.
But then if you pull out one of those, it's going to take the bits from that one and move it. Exactly.
Yeah. It's called parity. And what it is mathematically it's A plus B equals C, right? So you have, if you take one of those away from the algebraic equation, you can still figure out the other. So they've said, if I take file A plus B, it will equal C. But then if I lose B, right, now I can go back and say, well, B was this, and rebuild B on a new blank hard drive because it's got the math, and it's doing all that mathematical equation in the background. Yeah. So realistically, to do this, the NAS is the biggest investment you're going to make into your data storage, but it is something that will stay with you for the longest time. I have a 2013 edition Synology NAS that has been running 24/7 since 2013. So one of the really cool things about Synology, when you run this system, I can expand the disks as I go along. Once I've got all 5, and if I'm getting close to that 24 terabytes, instead of going down in redundancy, I can replace that 8 terabyte disk with a 10 terabyte or a 12 terabyte or a 14.
What happens if if you lose power in your house?
It will be off. Yeah. So this is going to be as good as the power in your house. And one thing we didn't talk about here is like getting a battery backup.
For this?
Yeah.
Okay.
Because it protects from surges.
Right.
So an UPS or an uninterruptible power supply protects your computer equipment from surges. You should always have a surge protector, even laptops, everything. Power is protected by battery, right? And you want to make sure so it does a clean shutdown because you don't want to just unplug a server ever. That's really bad. Your investment, like I said, it's your biggest investment. It's $1,000 for the enclosure in this case. There are lower scale, higher scale. This is kind of the sweet spot based on what I've spent a lot of time looking at these. And then 8 terabyte right now is kind of the sweet spot for hard drive costs. It's getting closer to like 12 and 14 terabyte disks, but like an 8 terabyte is going to be around $200 a disk. So again, you're at $1,000. So you're at basically a $2,000 investment to get 24 terabytes of very reliable and pretty fast storage.
Ultimately, like, the data is not only the product, but it's also your reputation. You go out and fly an expensive job and you lose all of that data. You're not going to charge the client for that because you're not, but also that client's going to not maybe hire you in the future because if you've
not delivering your products is a surefire way to not have to worry about getting called again.
Exactly.
The sweet spot right now seems to be about 2.5 cents per gigabyte for hard drives. I use like a website called PC Part Picker, which has a search tool, a parametric search, and you say, this is the type of hard drive I want. These are how many gigs it needs to be at minimum or terabytes. And then you can sort by price per gigabyte. You want to buy NAS edition hard drives because A, they're designed to be running 24/7 for longer periods of time. They're also designed to work in a higher vibration environment. When you have 5 hard drives side by side sandwiched together, and this one's working and this one's not, there's going to be more vibration. So a NAS hard drive is designed to work on that. Cloud storage. We use Google Drive. There are multiple options out there. There's Backblaze, there's Microsoft, there's Apple. Synology will actually work with quite a few of these. So Synology works with Dropbox, Microsoft, and Backblaze. Google Drive, for the most part, it works quite well for what we do in our use case. And what I mean is it's expandable. It's relatively cheap. When you buy the business standard, you get 2 terabytes per user, and then it's pooled. So if you have 10 users, you've got 20 terabytes. There's a higher tier, you can get 5 terabytes per user. And then there's also effectively like an unlimited ability. So you can really scale up your storage requirements.
If you were just one person and just wanted to have a little backup, I pay Google, I think $2.50 a month, $2.50 a month for 1 terabyte.
I was going to say I do the same. It just, it's like $2 or something.
And I use the family plan, the Google One family plan at home. It gives us 2 terabytes between my family. I think it's $15 a month or something like that. If I had my way, I would consolidate everything onto one plan just because it becomes searchable. And Google's great for that because you can run your email on it as a business. You can run your storage on it. You can run your apps, your productivity. How does our workflow work? Well, if I'm on the road or at home, if I'm offloading data from an SD card, I'm going to put it into my Mac or my PC, and I'm going to most likely dump it to the portable SSD first. If I'm dumping an SD card at home, or if I'm connected to my desktop and a fast internet connection, I'll probably dump it right into my cloud storage. Google Drive has the ability, like I said, to do offline sync, where I can bring down a cloud folder and make it appear on my Mac or my PC as if it's on my hard drive in my computer. And for a short period of time, when I'm adding something new to it, it is on my hard drive of my computer. So if I take the files that are on this SD card and I plug them into my Mac right now, inside my Google folder, I create a new folder and drag and drop them in, and it's a 100 gig video file. If I'm not connected to the internet, it's going to stay there on my laptop and on nothing else. But if I'm connected to high-speed internet, and by high speed, I mean like 100 megabit or better. Like, we got to be serious here. Like, when you're moving this kind of stuff, you need fiber. You need something that's got a strong, solid upload speed. Most coaxial internet providers, so anyone that uses the cable modem style, it's not a very high speed upload. It's fast down, right? So at home, I use fiber. It's 1 gigabit in both directions. Same in most of our businesses these days. Fiber is the way to go, not fiber-based internet. Fast internet, both directions. If I'm going to put it on my laptop, I can put it into my Google Drive on my laptop, and I can turn on Google Sync, and it will start carrying that file up to the cloud. So now it's going to go up into the cloud, into my Google, into our working folder that we've got all our naming scheme. It will then be immediately available on any other computer that has that parent folder set up as an offline sync. It'll start downloading it to that computer. So the risk you got to watch out for is, do you have enough hard drive space on these computers? Because if you move 100 gigs from your laptop up to the cloud and then it goes to someone else's, do they have 100 gigs free? Surprise, here it comes. On the other side of it, because we're using Synology, I have a bilateral, so a two-way sync with our NAS as well. My cloud storage, then that 100 gig file is immediately also being downloaded back to the NAS on that redundant array, and it shows up at the NAS level as if it was not on the cloud. It just becomes a physical file in the hard drive. Then I can deploy snapshots for long-term versioning, and I could use the NAS's own built-in backup features as well. And if I wanted to get really crazy, in my initial drawing, I put an offsite copy of my NAS, like have a second NAS that takes a full copy of the first NAS. So now you're not only cloud geographically independent, but also fireproof because you've got an offsite backup copy. 1 is none and 2 is 1. Because that NAS is in my office, I have high-speed direct connection to the NAS. I don't need to worry about the cloud. The data's there. If the internet went down, I've got everything backed up physically on site. But again, if my server went down, I have everything backed up in the cloud. It's 1-to-1 because our cloud storage is expanding and it's relatively inexpensive. So we haven't run out of space. Once I'm done the project, say I'm editing or something, I can then go into that cloud storage and make a client portal, depending on like security. Google's pretty good for this. I can set up a customer facing link, send them the link, and they can download the files directly from that. And I haven't run into too many files that it won't let me store in Google. That then delivers the files to them. I don't have to pay for another third-party cloud transfer service.
What happens if you leave this little thing in your car and it gets really hot in there?
This thing?
Yeah.
Some of these are pretty rugged. Like this thing, like when these things are running, they get pretty hot already. Like this one's actually it has a heat sink inside it because these ones would get like 60, 70 degrees Celsius. If they're working, like if you throw a ton of files at it, they can get pretty hot. So sitting on a dash in a car, probably okay, but certainly not great for it. Static shock is definitely something you want to watch out for. Like even me just handling this because it's an open PCB, like it's not a good idea. I dump my cards every day. I should dump my SSD once a week. If I were starting off from scratch and I had nothing and all I wanted to do was like get a Mini 3 Pro or a Mini 4 Pro and start a drone business tomorrow, get the drone, get a decent laptop, get a decent SSD, get a decent card, and get a cloud subscription to like Google Drive.
So start with the cloud and then work your way up to the
because
NAS.
the cloud for free, you get 15 gigs, right? If you go to the first paid plan, you get a terabyte, I think it is. Like that's a lot.
Do you think that would be enough to start out with though? Because
Totally.
obviously, yeah. Because now you're still doing what you said. You still have it on 2 platforms kind of, and then.
Yeah, exactly. Like let's say your first shoot is real estate. You're probably going to generate 60, 70 gigs of data. You're going to edit it. You're going to deliver it. Are you really going to need all 60 or 70 gigs of footage from that house that is going to sell once in the next 5 years? No, that's a perishable thing. So you can prioritize how much you need to store and archive. Do you need to keep your client's data forever? No, absolutely not. You need to build into your data management plan, how long am I going to keep this work for? Does this have a really long lifespan for training material or something like Coastal? Yeah, sure. Probably we want to keep a lot of stuff. 12 months to 2 years, I think is reasonable. But you have to have it in your contract because if you don't have anything in your contract, there's implied liability that you need to keep it in perpetuity. So a hard drive sitting on a shelf is the most dangerous position that a hard drive can be in. Not only because it could fall off the shelf, but also it's called bit rot. If a magnetic storage device sits on a hard drive without power on it, it potentially has a risk of over time rotting because it's not doing self-checking or error correction on it. When its hard drive is running, it's constantly checking its file system. It's making sure, is this bit healthy? A magnet could pass by and flip a bit from 0 to 1, right? That one little storage bit. And if it does it to enough, it's going to rot the data and it's going to be useless. If you think, oh, I'm just going to buy a 1 terabyte disk, store everything on it and put it in a safe deposit box and not think about it for 10 years. Do not count on that data being there in 10 years. Kristen said here, I had a wedding client ask me for their photos 5 years after their wedding. I had all the exports still so I could send it to him, but I didn't keep the RAWs, so I couldn't charge them for adjustment or re-editing. Another client messaged 2 years later asking for the rights to all the photos from a particular shoot. So I sent them an invoice for the photos. Yeah, because maybe they didn't initially pay for the rights or everything else. So he made money back on his investment in storage there because he continued to have an ongoing business relationship. I'll fall back on that. I said, I thought the more a disk gets used, the more likely it is to fail. Yes, that's also true. So there's kind of a medium between not using a disk and overusing a disk. Solid state disks have a finite read and write limit to them. So that means that they can only do, let's say 1,000 terabytes can be written to the disk because every time it does it, it's an electrical change and eventually it's going to wear out. They actually do have life indicators on them in software. You can put them into like a health monitor and see, well, this hard drive's at 98%. Yeah. This one in particular, I think I've had for 10 years and it was my primary, like main hard drive, my C drive on my Windows computer for years. and it's still like 97%. Yeah, and it'll warn you at a certain threshold. And what it's doing is it's as soon as those bits are no longer good, it ignores them and it starts reducing your capacity. Because even if this says it's 500 gigs, it's actually maybe like 550 gigs or something like that. And they just reserve some capacity for wear and tear. All right. Well, I think we're going to call it there. We're at an hour. Thank you everyone for joining us. If you found this of value, please give us a like. And if you want to see more content like this, please be sure to hit that subscribe button. And we'll see you on the next episode of Coastal Drone Weekly Live. See ya.